All right, everyone, get ready because today we're going deep on something pretty wild.
Yeah, this is a really cool one.
We are diving into a theory that flips the script on how mammals took over, rose to the top. We're looking at an article from Eons called The Fungal Theory of the Age of Mammals.
Catchy, right.
But honestly, don't let the title fool you. This is some seriously mind-blowing stuff. So picture this. The asteroid hits, wipes out the dinos, and you'd think, well,
Reptiles, right.
yeah, reptiles, they'd be the ones to bounce back.
Right, I mean, they need less food.
Totally. They're tougher, more adaptable. At least that's what we always thought.
You'd think they'd be perfectly set up to rule the post-apocalyptic world.
Right, but they didn't. Mammals did.
Exactly.
So what's the deal?
Well, this is where things get interesting. This is where the fungal infusion mammalian selection hypothesis, or FIMS, comes in.
Yeah, I mean, FIMS. Okay, lay it on me.
Basically, the theory suggests that the asteroid impact, it might have actually triggered a massive, like a global fungal explosion.
Wait, a fungal explosion? Listen.
Think about it. After the impact, you've got darkness, cold temperatures, dead plants and animals everywhere.
Right, a recipe for decay.
The perfect conditions for fungi to thrive.
Ah, so the asteroid basically served up a giant fungal buffet.
Exactly, and there's evidence to back this up. When we look at the fossil record, there's a huge spike in fungal spores right at the KPG boundary.
That's the layer that marks the asteroid impact, right?
Yep, which really points to a massive fungal bloom happening right as the dinosaurs vanish.
Okay, now that's some pretty convincing evidence. But how does this explain why mammals thrived? Were they somehow immune to this fungal takeover?
Well, not immune, but more like resistant. Cold-blooded animals like reptiles, they're way more susceptible to fungal infections than warm-blooded animals.
Ah, so their warm blood was kind of like a built-in defense system against the fungi.
Exactly. Mammals and birds, with their constantly higher body temperatures, they were better equipped to fight off those infections.
While the reptiles, they were left vulnerable.
Wow, that's incredible. So you're saying that mammals might owe their dominance not just to brains or adaptability, but to this, like, random biological quirk.
Yeah, it kind of throws a wrench in the whole survival of the fittest idea. It might be more about chance and very specific traits that determine who makes it.
I gotta say, this is seriously mind-blowing. To think that something as tiny as a fungus could have completely reshaped the course of evolution, it's amazing. It makes you wonder how many other seemingly small things have had a huge impact on the world we see today.
You're telling me?
So this fungal bloom, it sounds like a major event. What else do we know about it? What kind of fungi were we talking about here?
Well, the evidence seems to point to a group called ascomycetes.
Ascomyces, okay.
Yeah, it's a really broad group, includes tons of different fungi.
Mm.
Some you might even know, like truffles.
Truffles, like the fancy mushrooms.
Yeah, those truffles. Morels, too.
Oh, wow.
And get this, even baker's yeast is an ascomycete. Hold on, so you're telling me the same fungi that give us delicious mushrooms and bread could have played a part in wiping out the dinosaurs?
It's not quite as straightforward as that.
Right, of course.
But it does show how diverse and important fungi are. We often don't even realize how much they do.
Yeah, true. They're kind of the unsung heroes of the natural world.
Absolutely. They break down all that dead stuff, help recycle nutrients, even keep ecosystems in check.
So this wasn't just one bad fungus taking over.
Nope, not at all. It was probably a whole bunch of different fungi, all taking advantage of the chaos after the asteroid.
Makes sense. Everything was up for grabs.
Exactly. Tons of decaying matter, weakened ecosystems. It was the perfect opportunity for fungi to explode.
Like the Earth turned into a giant fungal breeding ground.
You got it.
And mammals, with their warm blood, just happened to be better equipped to handle it.
Yeah, they weathered the storm, so to speak.
While the reptiles, they got hit hard.
And this fungal bloom wouldn't have just affected the animals.
Oh, right. Everything's connected.
It would have had ripple effects through the whole ecosystem. Some plants and insects probably thrived because they had a good relationship with the fungi.
So it wasn't as simple as winners and losers, more like a reshuffling of the whole deck.
Precisely. And this whole FIMUS hypothesis, as crazy as it sounds, it's gaining traction.
You're saying the evidence is adding up.
More and more fossils are showing this increase in fungal activity after the impact.
That makes a lot of sense. But this makes me wonder, what about now? Are there any modern-day examples of fungi impacting animal populations?
Oh, absolutely.
Yeah.
We're actually seeing a pretty worrying rise in fungal diseases.
Like what?
They're affecting all kinds of species, bats, amphibians, even trees.
Wow, I had no idea. Do you think there's a connection between these modern outbreaks and what happened millions of years ago?
It's a good question. Researchers are definitely looking into it. One theory is that things like climate change, habitat loss, they're putting stress on animals, weakening their immune systems.
Making them more vulnerable to the fungi.
Exactly. It's almost like history repeating itself. Weakened ecosystems give fungi a chance to take hold.
That's a little unnerving, to say the least. I guess this ancient event might have some important lessons for us today.
It definitely does.
Yeah, it makes you realize how interconnected everything is.
Absolutely. And how our actions can affect things in ways we might not even expect.
It's like we're not just watching nature, we're a part of it.
Right, and our choices, they have consequences for the whole web of life.
And speaking of consequences, this FIMS hypothesis, it makes you think about the role fungi might play in the future, too.
Exactly. It raises some big questions.
So what do you think that future might look like? What can we learn from this whole FIMS thing to help us deal with a changing world?
Yeah, it's a bit freaky to think about. Fungi, I mean, we usually don't give them much thought.
Yeah, out of sight, out of mind, right?
Totally. But this FEMS thing, it's like a wake-up call. We got to pay attention.
We do. They're way more influential than we realize. So what do we do? I mean, how do we use what we've learned from this to face the challenges we're seeing today?
Well, one big thing is research. We got to understand fungi better.
Right, like we need to know more about all the different types.
Exactly. Their roles in the ecosystem, how they can help or hurt us.
It sounds like we're just starting to figure them out.
Oh, yeah. We've only identified a tiny fraction of all the fungal species out there. Millions, probably.
Wow, millions.
Who knows what we'll find? Maybe new medicines, maybe new threats. We're just scratching the surface.
It's like a whole other world waiting to be explored. And this fungus thing, it suggests this fungal world might hold clues about our future, too.
Exactly. If fungus is right, then figuring out how environmental changes lead to fungal outbreaks, that's crucial.
And so we can avoid another one, right?
Yeah, that's the idea.
Are you saying we could see another global fungal pandemic?
It's not out of the question. Climate change is messing with ecosystems, stressing species.
Making them more vulnerable.
Right. It could create the perfect conditions for new fungal diseases.
That's a pretty scary thought. What can we do to get ready?
Well, we can improve how we track fungal diseases, put more resources into developing new treatments.
And try to prevent them in the first place, right?
Exactly. Protecting biodiversity, reducing environmental stress, those are key.
It all comes back to understanding how our actions affect the whole system.
It does. The FIMS hypothesis is a big reminder that we're not separate from nature.
Yeah, we're part of it.
And our choices, they affect everything.
Well, I'll never look at a mushroom the same way again, that's for sure. This has been a wild ride. Never thought something so small could have such a huge impact.
Yeah, it really makes you think.
It does. Thanks for taking us on this deep dive. It's amazing how the most unexpected things can lead to such incredible discoveries.
My pleasure, anytime. And hey, next time you see a mushroom, take a second to really appreciate it.
I will.
It might just hold the secrets to our past and our future.
That's a great point. Well said. That's it for this deep dive, everyone. Thanks for listening. Until next time, keep exploring and keep diving deep.